Gentlemen, we're BMW Supra, and we've been tasked with doing a presentation on the TPS sensor and how it works. The team here, we've got David, Eduardo, Andrew, and myself.
Okay, so here we have a throttle position sensor, or a diagram of one. It is a 3-wire variable resistor, which is a potentiometer. We have our 5-volt reference, our signal return to the computer, and our ground return. Here is a diagram of the sensor at idle, which would give off a half a volt signal to the computer. Here is a wide open throttle. You see it's increasing to 4.5 volts, which would indicate wide open throttle. And here we're going to show you a testing procedure for it.
Okay, and continuing on Eduardo's description of the throttle position sensor, here you see an indication where the swing arm is right at the beginning of the resistor. And as the swing arm moves down the resistor, more and more resistance results in more and more voltage loss. In this depiction, it's even before the beginning of the resistor, so the actual voltage loss is very close to zero. And as you can see, we get a 4.5 volt return, indicating, wide open throttle. Click. In this depiction, it's in the middle of the resistor. So it's lost about half of the voltage. As you can see here, 2.5 volts. So that's about mid-throttle. Click. This kind of gives you a holistic view of the way it works. At each point in the resistor, you can return a different signal voltage based on where the arm is, based on how far open or closed the throttle position sensor is. Click. The PCM takes the voltage that comes back in the signal return, goes into a previously stored lookup table, and pulls out the exact value that it wants to send through the system to determine how much fuel needs to be applied.
Here we have 3 trouble codes that are typically associated with the throttle position sensor. Our first signal, or first code, says that we have a low voltage signal, which would indicate that our sensor is shorted to ground internally, or one of the wires in the harness itself is shorted to ground somewhere. Our second trouble code indicates that we have a high voltage signal, meaning that inside of the throttle position sensor, it would be shorted to the 5-volt reference on the high side. Or, once again, we have an open in the wire harness itself. Our third trouble code says that the throttle position sensor does not agree with our map signal, indicating that you either have a defective throttle position sensor or we have incorrect vehicle speed sensor values being inputted. As a technician, you would run the DTCs and find out which code we are dealing with. For instance, if we're here with the low voltage, we would take our DMM and we would back probe our wires while actuating the throttle position or the throttle plate and verifying whether or not that voltage changes or not.
Right here we have a wiring diagram that technician will be putting up in order to do diagnostic and repairs to the throttle position sensor. We have the PCM right here, which will be supplying the 5-volt voltage and also acting as the ground to our throttle position sensor. The throttle position sensor will get, based on the percentage of the throttle opening, will give us the voltage to the PCM.
This is an oscilloscope set up to read the voltage from the back probed wire 3 signal wire of the TPS sensor connector. If you also look down here, this is the throttle itself, which can be manipulated to simulate open and closing the throttle with the gas pedal. So we've got the scope set up to read in basically half a volt divisions, the change in voltage on the wire. So let it go back to idle. And what you see is we're at less than a volt. We're at about 3/4 of a volt, which simulates an idle position from the throttle position sensor to the engine. Now my colleague is going to open the throttle completely. Okay, now you see it's at close to 5 volts. It's about 4 3/4 volts. at wide open throttle. Okay, and now my partner is going to release it back down all the way, and we go back to the idle of about 3/4 of a volt. Okay, so he's going to do it really quickly so you can see the transition from high to low. There you go, high to low, high to low. So it goes from 3/4 of a volt up to 4 3/4 of a volt in the range. Okay? Thank you.